Good afternoon, ladies and gentlemen. Can you hear me and can you see the presentation?
Yeah, we see it, Mr.
Great. Thank you, Mr. Khalid. The subject which we will discuss today is, and which is covered in this presentation, is about challenges for mining into metals because of overall digitalization, and how digitalization generates new risks and new opportunities for the mining and metals industry. So it's a little bit different than compared to presentations you saw before. And the actual goal of the presentation is to answer the question, how to ensure the business continuity in the new normal. And okay, this is about me, and Mr. Khalid has already introduced me. I really have quite a big experience in the mining and metals industry, and my current area of activity is industrial simulation and predictive modeling and advanced process control systems in mining and metals. But before we begin, the organization committee actually asked me to start with a general description and general definition of the current and possible industry trends, risks, and opportunities. And then we will discuss these risks.
The voice, we cannot hear it, Mr. Dmitry.
Okay, I'll try to speak louder.
No, it's cut it. It's fine, but it's cut the voice. Now it's written back.
Okay. So we will discuss how to convert these risks and opportunities into certain actions we need to undertake to make sure that the mining and metals technology corresponds with the overall development of the world and supports it. And therefore, let's begin with what the new normal is. This term has become very popular this year at the COVID-19 time. However, I suppose that the COVID-19 is not the major feature of the new normal. COVID just speeds up what is already going on, warns us about new possible challenges in the rapidly interconnecting and shrinking world. But the real new normal is the fourth industrial revolution. When we look at this chart, which is on the left of the slide, we see that just like everything in the world, just like the universe, just like the macro and micro world, so everything is moving cyclically. And the major cycles are called industrial revolutions in the modern world. And we are facing now the fourth industrial revolution. However, this revolution has not started yet, I believe. Because if we have a look at the current industrial trends, here on the right top of the slide, we see that currently we have reduction of time to produce. We are really producing quicker. We have customization, connectivity, quality of the end product and quality of the processes. Cyber systems are integrated into production. Global industrial networks are developed. And we have distributed architecture for data storage and calculation. And we also have quite a significant progress in the environmental issues. But why do I say that it is not the fourth industrial revolution yet? Just because these processes are running slowly and these processes are not interconnected. I believe that very soon the humankind will reach a certain point, let's call it a point of bifurcation, where all these trends get together. And here we may say that we will face very soon the real convergence of nano, bio, info, and cognitive technologies. And it will finally generate the explosive technological growth. And only then the fourth industrial revolution begins. The speed will be tremendous, and changes it will bring will be fundamental. So the question is, how the mining and metals industry meets with all these new challenges, what kind of risks and what kind of opportunities it will face. What actually the fourth industrial revolution means for the mining and metals. You see on the left of the screen, the metallurgical plant of the past. A lot of smoke, a lot of people are going to the shop floors and also underground, and the labor conditions were terrible, the production rate were just very slow. But what about now? We believe that the fourth industrial revolution will give us quite a huge list of different opportunities. First of all, what will be developing very fast? Transportation networks of everything, of energy products, of end products, of ores, metals, etc. Transportation of power, transmission lines, substations, etc. Wide area networks, city infrastructures, vehicles with alternative power supplies, treatment of waste, defense industry, whether we like it or not, the defense industry will receive a new impact for development. But in fact, what will it mean for mining and metals? First of all, the world will require more pipes, more rails, more cable and wires. And finally, I suppose that the all metals industry will develop very, very fast to meet the global demand in metals. It concerns ferrous metals, non-ferrous, and rare earth metals. What kind of risks we are facing now? The first risk, I suppose, is the alternative sources of power. So this actually means that we are already going away from the coal industry and to the sun or wind or hydro energy generation. We will also have so-called alternative metallurgy, which allows to produce metals without coking coal. Another interesting risk for the mining and metals is development of petrochemical industry, because most likely petrochemical products will substitute the metal products. And of course, we still have huge environmental risks. You know that sometimes in different parts of the world, we have really environmental disasters, and people die, and nature dies, etc., etc. So this means that very probably the steam coal and coking coal production will decrease in the future. And there are two questions we ask ourselves. The first one, how to make production efficient to explosively growing sectors, I mean in the metal sectors. And the second question is actually very similar to the first one, how to make production efficient in the declining sectors, because we will not be able to close all coal mines just in an insignificant time period. And the major answer to both questions is, to back up the fourth industrial revolution, we need total automation and intellectualization of production processes in mining and metals. And here I would like to introduce the term of the smart enterprise. It's not a digital enterprise, it's a smart enterprise, which actually has four distinguished features. The smart enterprise has to be efficient, it has to be safe, it has to be environmentally friendly, and continually improving. On the bottom of the screen, you see the typical value chain for coal mining company, which starts with geology and mining, and then ore transportation, then processing, storage of coal concentrate, again, concentrate transportation, and finally, loading of the concentrate to the final customer. In fact, the ore processing is very similar to it. Of course, metallurgical plant is a little bit different. But again, when we are talking about efficiency, first of all, we are talking about the maximum production rate. That means that whatever we mine, we have to process. And here also we are talking about the minimization of consumption of different materials or energy, be it power, reagents, etc., etc. And what we have discussed earlier today with my colleagues, the minimization of outages of equipment. Beyond this, we have to reach, and this is very important, we have to minimize time of employees working in hazardous areas. As the ultimate goal, I think, I will say this ultimate goal is to get all personnel out of the ground, out of hazardous areas, because actually people have to live happily at the sea, under the sun, and they should not work underground. There should be automated, autonomous equipment which do this function. Of course, we should have the, let's say, we should move from post-accident damage response to accident prediction, which we have already discussed earlier today. And we should run different simulation models, such as what-if analysis for technological processes and for management processes, for example, production planning. I will not cover the environmental issues in details because I have said several words about it already, but what is also necessary, and the previous presenters touched this issue, is that the future enterprise, the future smart enterprise, should be continually improving. This means that it should have a certain management system which consists of three things: people, processes, and instruments. And digitalization is just one of the possible instruments. So the smart enterprise, gentlemen, is not just a digital enterprise. The smart enterprise is the combination of many, many systems still managed by people, clearly defined processes and instruments. This is the, what we say smart. Later on, in my presentation, I will mostly concentrate on the processing part of the value chain, and I will try to open different aspects of predictive analytics and simulation modeling for the processing plants. Actually, how to get from a regular process to a smart process. This is the example, the process: metallurgy, zinc production, and one of the first sub-processes is zinc concentrate roasting. And the technology is that this is the, in the yellow picture in the middle of the slide, is the fluidized bed furnace, where the input product is the zinc concentrate or blend of different zinc concentrates. The output product, the main output product is the zinc cinder. And finally, also the technological mode is regulated by the air and oxygen, which are just, and some water, which are just also go into the furnace. So the step one to come from the regular furnace to the smart furnace is what we already having now. It is SCADA. The current system that controls the process and controls the conditions of the devices which is used in this process. So we have the technological mode control in SCADA and condition control in SCADA. Suppose this is not enough to control the process as is. And the second step is that we just come from just one device, one furnace to the whole process, where we have the zinc concentrate or blend of zinc concentrates. We have a conveyor, we have this furnace, and so everything is working together. In this step, we can already regulate or control the process. We can control what kind of blend of or chemical composition of zinc concentrates we have for an input. We can set up the mode, the technological mode, assuming that we fix the parameters of the zinc cinder. But now, how it goes? Usually we have the operator who controls the process. The major action in this step is that let's substitute this operator with something automatic. Of course, this automatic will not be this robot exactly, which is shown here in the picture. That will be the automatic algorithm that regulates three things. Parameters of the input product, zinc concentrate, parameters of the output product, zinc cinder, and parameters of the technological mode. It should go without human interference. This is very important. And this is the way we go. But I suppose this is actually not enough, because there is step three, which I call the advanced predictive process control. We see here the same picture of the process, yes? The furnace, the zinc concentrate, zinc cinder, and regulation or control. And we added to this control process another important thing, which we call statistical optimization based on historical data. Imagine this furnace is operating for 5 years. And SCADA actually collects all data necessary nobody knows for what yet, but the data exists. We may take this data, run a certain algorithm, which actually set the boundary conditions. And for example, let's optimize the blend of zinc concentrate for the technological mode is constant, and zinc cinder parameters are constant. And the system will allow to optimize the chemical composition of different zinc concentrates in the blend. Or we may say, let's, something different. Let's find the optimal technological mode, having the zinc concentrate constant and zinc cinder constant, again, based on historical data. And we can plan for it, we can act for it. This actually means, and this is very important, that we can suggest now what will happen in the future. and we can decide also now what to do with it. And this is when the control really becomes smart. Three steps to achieve the smart process. Smart, in this case, in this very case, the smart furnace. Same approach is for equipment predictive maintenance. We have the same furnace. And we may control or at least get the data about the furnace shell conditions and refractory conditions, which is the inner part of the furnace. It is made of a special refractory bricks. Because we are able to get different parameters from the furnace, be it a pressure, speed of the air, speed of the fluidized bed, and temperature, of course. We have all this data for 5 years. And exactly as the previous speakers noticed, we may create the forecast model which, based on the current or historical data, will finally tell us again today what might happen with this piece of equipment in the future.
5 minutes, Mr. Dmitry, for the question.
Okay. So this is about, this is the smart maintenance. So we have smart technological modes and we have smart maintenance. And the biggest challenge, so many people ask me what the business challenge in this process is. The biggest challenge is that the standard algorithm library, which defines these different processes, and we calculated there are several hundreds of different production processes in mining and metals. So these libraries and these algorithms simply do not exist. They are beyond SCADA. And those who creates these algorithms, who tests them and implements them, will become really efficient in the new normal. And the question is how to create this standard, what is needed, or who is able to create this algorithm. We believe that there are three things are needed. First of all, the software platform is needed that supports, you see, mechanical, physical, chemical, and processes, and also kinetics. This means how these processes are developed in time. And the second thing which is needed, it's personnel, data scientists, mathematicians, programmers. And the third thing, the last but not the least, is also personnel, technologists, and relations with major universities, because we know that this is actually the creation of such models is a scientific job. It's R&D, and it is mainly concentrated not in the plants, not at the mining and metal enterprises, but in the universities. And having resolved this challenge, I mean, when these algorithms are created, we will really be able to create predictive smart solutions and create the smart enterprise of the future that is efficient, safe, environmentally friendly, and continually improving. Thank you very much, gentlemen.